All right, so we're going to start looking at absolute value equations and then inequalities. So what does basically this even mean if I have absolute value of x equals 4 on this first example? Well, absolute value bars, what they end up doing is whatever number is inside of them, they make that number positive. If it's already positive, it stays positive. But if it's negative, it switches to positive. So that means that when I look at absolute value of x equals 4, one of my answers is 4 because the absolute value of 4 is 4. But I also get a second answer because I need to think about, well, what about the negative version of this, that the absolute value bars would take the negative away? Well, negative 4 would be what works for that, because I can absolute value a negative 4, and all it does is take away the negative and make it 4. So what we're going to find is that the vast majority of the time, we will get two answers for these equations, just like we did with quadratic equations. And when we look at the graph of absolute value, we'll see some similarities that will kind of help us understand why that is. But for now, we get two answers. That's kind of how this goes. So on B, we have the absolute value of x equals -6. You could think of this as a trick question or a question that's supposed to have us explore a particular point. If absolute value bars make what's inside positive, is there any way that this side could ever equal a negative number? And the answer is no. No matter what I plug in for x, like plug in 6. Is the absolute value of 6 equal -6? Nope. What if I make it negative? It'd turn positive, still not -6. So any type of equation we at some point explore the idea of, what are our limits with this equation? When do we actually not get a solution at all? This would be a case where there is no solution to this. There's no answer that I can put in for x that will work. And it's all because of that pesky negative. Now, that doesn't mean that anytime you see a negative on the right side, that it's automatically no solution, although, that will happen from time to time. It's when you get to the absolute value equals blank, and you're looking at that you need that number to be positive. So on this set of homework, we've got relatively simple absolute value equations, meaning that the amount of steps it takes to get the answer is on the lower side. And then we will, in the next lesson, explore some more complicated ones. So on C, the absolute value of 3x equals 9. Well, there's two ways to think of that. Basically, what's happening is we're saying, I'm going to get from this 3x absolute value of 9, which gives me 9. Or I'm going to get absolute value of -9, which gives me 9. But what's inside the absolute value right now is 3x. So to figure this out, we need to say, well, what would make 3x equal 9? And what would make 3x equal -9? And this is going to give us two answers for us to, have for this, because we already pointed out that most of the time we get two answers. There's no solution is not two answers, and then if we were to have an equal 0, then that would only actually be one solution, because 0 can't be positive or negative. So this thing where we're looking at both the positive and negative doesn't actually work with 0. Anyway, 9 divided by 3 is 3, and -9 divided by 3 is -3. And let's think about that in the context of the problem. If I do 3 times 3, I multiply, and then I absolute value, and yeah, that gives me +9. But the same thing happens if I turn this into a -3. 3 times -3 is -9, but the absolute value of -9 is +9. Let's see on D. So x plus 4 inside the absolute value bars equals 7. So whatever we end up with inside of the absolute value bars is going to have to be either 7 or -7, because what we're going to do is we're going to absolute value whatever this is inside, and so whether it's a +7 or a -7, it'll give us this 7. Now, what is needing to be equal to 7 and -7? It's the thing inside the absolute value bars, so x plus 4. And so the steps are the same here. Then I'm going to -4 on both sides. But the answer we get is not the same. It is probably not going to be a plus or minus like it was on the last one. So 7 minus 4 is 3. But -7 plus a -4, those are two negatives that add together and give me something more negative. So x equals -11. In general, if you're just trying to go for like, what are the steps that I have to do? What do I have to remember? To get rid of absolute value bars so that you can just write 2x minus 1, we need to write two equations. We need to write one with +11. We need to write one with -11. And this is actually kind of a unique function in math that, like, we don't have a thing that just gets rid of absolute value bars. Like, if we have a squared, we have a thing called a square root that can cancel that squared out. And that's going to be the case for lots and lots of functions, that we have an opposite to it. Absolute value, we don't have an opposite operation to it. We just have to say, okay, this either has to be positive or negative, and solve our two equations. So I'm going to add 1 and then divide by 2. So x equals 6. I'm going to add 1. Divide by 2. And get x equals -5. There's my two answers. And we can always check these by plugging them back in. It's always a thing we can do with equations. F. Okay, so this is where, if you're feeling confident, you can practice this, right, on your own. So to get rid of the absolute value bars, I need to say 6 minus 4x equals +6, and 6 minus 4x equals -6. Before I forget, want to mention that because of the way these equations work, we are fairly likely to get fractions as answers. I don't know why I didn't make sure one of these examples gave us a fraction, but there we go, unless this last one does, which, nope, I don't think it does. So this answer is x equals 0. And I mentioned that 0 can cause us to have only one solution, but this is not one of those times, because I got 0 after I started solving this first equation, and so when I subtract 6 on this side, I don't get 0 on the right because they're two negatives. I get -12. If you do end up with something that does not divide evenly, then what we do is we just write it as the simplest, most reduced improper fraction that we can. You don't have to change it to a mixed number. You can if you want to, but that's what we do with fractions. Thanks for watching.